Hi children, so I want to help you do problems number 3 and then probably problem number 2. So in these inequalities, these are not solved for y the way they were yesterday, which means that I actually have to solve this a little bit differently so that I can graph my line. So if I look here, one thing that I do notice is that 12 can easily divide into 24, and so can 8. So 24 is a multiple of both 8 and 12. This makes my job a lot easier because this means I can actually make a t-chart and choose values for x and y to plug in to figure out 2 points so that I can draw this line. And because 24 is a multiple of 8 and 12, I can actually decide to let x equal 0, and then for my second point, let y equal 0. So if I let x equal 0, then I have 12 times 0 plus 8y is less than 24. Okay, which means I have 8y is less than 24, which means I would divide both sides by 8, and I get y is less than 3. Okay, remember when we're generating points, I'm actually pretending this is an equation, so I know that this would be 1.03. And then I can do the exact same thing by plugging in 0 for y now. So if I plug in 0 for y, I'm going to have 12x plus 8 times 0 less than 24. 8 times 0 is 0, so I just have 12x less than 24. If I want to figure out what's exactly on the line, I would divide by 12, and I get x is less than 2, but I know that represents a point on the line, so that's actually 2, 0. After that, I would use these 2 points and this symbol to figure out how to draw my line. Since this is just less than, I know this is a dashed line. So go ahead, take a look at your graph. We're going to plot the points 0, 3, and 2, 0. So 0, 3 would be here, and 2, 0 would be here. It's helpful to use a ruler right now if you have one to draw a dashed line going through these 2 points. My line's not as good as your line will probably. Now the last thing I need to do is to check a point. Yesterday I told you we can check any point, but just for ease, I'm going to check the point 0, 0. So this means I'm going to plug in 0 for x and 0 for y and see whether or not it makes my equation true. So my original equation was 12x plus 8y. So I'm doing 12 times 0 plus 8 times 0, and I want to know if this is less than 24. Well, 12 times 0 is 0, and 8 times 0 is 0, and 0 plus 0 is 0, and yes, 0 is less than 24. So I now know this is true, which means my solutions are on this side of my inequality line. So there's problem 3. Let's take a look at problem 2. Okay, so if I'm looking at this problem again, this problem is not solved for y, which means that I have to graph it another way than I'm used to. But I do realize that this in front of the x is a 1, this in front of the y is a negative 1, and both of these will go evenly into 5, so I know I can actually solve this the same way I solved the last problem. I can plug in 0 for x and figure out what y would equal. Okay, so as I said, when we're graphing an inequality, it's helpful to pretend that this is actually an equation. So if I wanted, I could write x minus y equals 5, just if it's simpler for me to understand. I'm plugging in 0 for x, so 0 minus y equals 5, which gives me negative y equals 5. Now there's 2 ways to handle this. You can think about it and do some mental math, or you can divide both sides by negative 1. There's no shame in that. I get y equals negative 5. So there's one of the points that's going to help me graph this inequality. Then I would do the same thing for y. I would plug in 0 for y and figure out what x would be. Well, x minus 0 equals 5. That means x equals 5. So here are my 2 points. I would graph these 2 points, and I would make sure that I'm drawing a dashed line because this is a greater than symbol, which means I have a dashed line. So now looking at our graph, I'm graphing the points 0, -5. So 0, -5 would be here. And I'm also graphing the point 5, 0, which would be here. And this is a dashed line, so I'm connecting these and drawing a line that is dashed. My final step is to check which side is true and which side is false. Again, just for the simple ease of it, I'm going to check the point 0, 0. This means I'm plugging in x is 0 and y is 0 into my original inequality to see if it makes my statement true. So if I do x minus y greater than 5, I want to plug in 0 for x, 0 for y, and see if it makes it true. Well, 0 take away 0 is 0. Is 0 greater than 5? No, this is false. So I go back to my graph and I know this side is false, which means I have to shade the other side because that is the side that must be true. And there you have it. We're done. Go ahead, finish up problems 1 and 4, and I'll see you tomorrow.